Hi guys, my name is Terry. In this video, I'm going to go through the SPM trial paper year 2022 for the subject Additional Mathematics for the Selangor paper, and this is paper 2, set 1. Okay, let us begin with question number 1. So in this question, we have a triangle OPQ on the Cartesian plane, and this is a question from the chapter Vector, and O is the origin. Now, R and S lie on straight line OQ and PQ respectively. The ratio of OR-RQ is 2 to 1. Now, let me label here. This is 2 and 1. And QS is 5 times of SP. That means this is 5, this is 1. Okay, you're given vector OP, you're given vector OR, you're supposed to find coordinate point Q. So first of all, I think I'll just do it here. To find coordinate point Q, first we find OQ, a vector OQ, and I'm going to write in the form of column vector. I prefer column vector rather than I and J form, because I and J form, you have to write I and underline it, write J, underline it, a lot of work, right? So now, to go from O to Q, you can see OQ is on the extended line of OR. We already know vector OR. Yeah, if you want to write in coordinate form, is 2, 4. In column vector is 2, 4, like this. This is vector OR. OQ is longer. In fact, is 1.5 times longer, or should I say 3 over 2? This is 3. This is 2. So it's 3 over 2 times of OR. And since we know vector OR, right, I'm going to write in this form 2, 4. Let us multiply inside. Yeah, 3 over 2 times 2 is going to give us 3. 3 over 2 times 4 is going to give us 6. Yeah, there you go. That's vector OR. OQ. However, we're supposed to write in coordinate form. Coordinate, we have to write coordinate of Q as 3, 6. All right, that is Roman 1. Now, Roman 2, we are finding vector coordinate of point S. Yep. So we can find vector OS first. Okay, I have 2 ways of doing. One is a standard way, one is a fast way. I'll show you a standard way first. To go from O to S, we can go from O to P, P to S. Now, some of you may want to go from O to Q, Q to S. You can do that, right? I think O to P, P to S is easier because it's shorter. Yeah. So let me just highlight for you. O to P, P to S is shorter way to go from O to S. So your OP, as we know, P is 6i here. In column vector, we write 6, 0. And PS is 1 over 6. The whole thing is 6. Yeah. PQ is 6. PS is 1. So we write 1 over 6 of PQ. And we know that PQ is quite easy to find. We can go P to O, O to Q. Now, personally, I like to use OQ minus OP. Now, for those who are not sure, how do I get this? PQ is actually P to O, O to Q. And PO is negative of OP because you're going in the opposite direction. Now, OP is going to the right. In this case, PO is going to the left. You put a negative, you plus with OQ. Put OQ in front, OP at the back, right? So it's OQ minus OP. Now, if you are not comfortable with this, you want to use PO plus OQ, go ahead. But make sure you put a negative in front of OP, okay? All right. So let us put your OQ inside, since we already know vector OQ from the earlier part, 3, 6, and we know vector PQ is 6, 0. So we put them together. This is 6, 0 plus 1 over 6. 3 minus 6 is negative 3. 6 minus 0 is 6. Multiply inside 6, 0. This is going to give us negative 1 over 2. 3 over 6 is 1 over 2. 6 divided 6 is 1. So 6 minus half. You can write 5.5. Or we can take 6 times 2, 12. 12 minus 1, 11 over 2 and 1. So that is vector OS. Okay, however, we need to write in coordinate form. So if you write in coordinate form, your coordinate of S is 11 over 2, 1. All right. So I have a shortcut way to show you guys, because I hope you guys are familiar with the divisor of line segment, the NX1, MX2, m plus n. So if you watch my previous discussion of other state paper, I've always explained how to use this formula for vector. It's actually quite easy. Now, I want to find vector OS. I know this is 5. I know this is 1. I already know vector OQ. My OQ is 3, 6. My OP is 6, 0. So a shortcut way will work like this. In coordinate, we have to do X and Y. In vector, we don't have to do both because we are dealing with only one vector, right? So in this case, for example, this is your M, this is your N, right? Your M must be multiplied with the opposite vector. So in this case, we take N equals to 1 times 3, 6. And then your M equals to 5. You multiply by the other vector, which is 6, 0. You divide by your total ratio. Your total ratio is 1 plus 5, which is 6. But normally we don't write divide by 6. We multiply with 1 over 6. So as you simplify this, this is 1 over 6, right? This is 33, 6. Okay, I should write in this form. When you multiply inside, 33 divided by 6 is 11 over 2. 6 divided by 6 is 1. Yeah, notice it's a lot shorter, right? I can get it in three lines, 3 steps. Okay, so that is part A. So for part B, we're supposed to find, determine the unit vector in the direction of RS. Okay, if you want to find unit vector of RS, RS is here. So first of all, we need to find what is vector RS. RS, I like to use OS minus OR. Yeah, as I explained earlier, you can do RO plus OS. It's the same thing. RO is negative OR. I just put the negative at the back, OS in front. It's always the second letter with respect to O minus the first letter with respect to O. Yeah, it's OS minus OR. Okay, my OS, I already have it here. 11 over 2 and 1. My OR, it is given earlier, 2, 4, right? 2, 4. So 11 over 2 minus 2 is 11 minus 4, which gives us 7. 7 over 2. 1 minus 4 is negative 3. Yeah, I know this number is not pretty because it is in fraction. So before you find unit vector, remember, what is unit vector? Unit vector for a vector R is a vector divided by its own magnitude. Yeah, we divide by the magnitude because we want to find per unit of that vector. Okay, the vector may have a magnitude of 5 units, so we're going to divide 5. We want to find 1 unit. What is the vector? Yeah, okay, let's find magnitude of RS first by taking 7 over 2 square, negative 3 square, square root. Okay, let's use a calculator. You can actually use a calculator. However, calculator would tend to simplify straight away. So I know some people may find a bit, how do you show working? Yeah, this calculator, the silver and the black and white calculator will simplify straight away. So I tell you what, I show you a bit of working. 7 over 2, you square it, all right? Then you add with negative 3 square. So you should get 85 over 4. All right, so this is square root 85 over 4, square root 4. You can write 2 straight away. Yeah? In fact, guys, you can put a square root answer straight away. Yeah, 85 over 2. Okay, now your unit vector, therefore, unit vector. Now, you normally we don't put RS with a cap. Yeah, normally this is not the notation. So it's okay to just call it vector U, unit vector, with a cap here. All right, this is the notation for unit vector. We take the vector, divide by its magnitude. Now, if you want to write in IJ form, right, then we have to write 7 over 2I minus 3J, right? And then you divide with the magnitude 85 over 2. Now, it's okay to write in column vector form as well, but column vector, we don't divide like this. We write 1 over square root 85 over 2, and then there's a 7 over 2 minus 3. Yeah, both ways are fine. So the challenge with this, or the problem is this, is that we want to simplify it. Yeah, the question already say simplest surd form. So we may have to rationalize the denominator. We can flip this upside down. So this is 2 over surd 85 with a 7 over 2I minus 3J. Now, this 85, we need to multiply top and bottom with Surd 85. So maybe I insert here. I multiply with Surd 85, top and bottom. As for the 2, I think it's better to just multiply inside because I don't want the 7 over 2 there. This will give us Surd 85, Surd 85 over 85, right? Yeah. And the 2 when I times in is 7i minus 6j. So that will be the simplest Surd form. Now, again, you can do the same for column vector with multiply inside. This will be Surd 85 over 85. This is 7 minus 6. Yeah, that will be in the simplest Surd form. Okay, let's move on to question number 2. So this is from the chapter Indices, Surds, and Logarithm. Okay, so the first part, we're given that the length of 2 diagonal of a rhombus is 2 plus Surd 3 and 3 plus Surd 48. So let's do a rough sketch. Since it's a rhombus, right? We can just do like this, draw a sketch like this. Okay, a rhombus is such that the 2 diagonal are always perpendicular. Okay, my rhombus doesn't look very perpendicular. Okay, let me just make it a little bit better like this. Okay, it looks a little bit more perpendicular. Yes, 90 degree here. So, but the main thing about area of rhombus is that they gave us the length of diagonal, right? I hope you know that rhombus is actually a form of kite. Yeah, to calculate the area of kite, we take this length of the first diagonal, length of the second diagonal. B, your area is half of A times B, product of the diagonal. Now, I know some people may take half of it. They may take half times base times height. They may split this into 2 and say, okay, this is the first triangle. This is the second triangle. I find the height of this. And then I take half times base times height times 2. It's the same thing. Yeah, you can say, like, for example, let me just say this is B. B stands for base. A stands for height, let's say. This is A over 2. This is A over 2. So half times B times A over 2 times 2, it is still half AB, right? Okay. Another thing is that for a kite, right, if I extend this kite, right, I extend this such that all 4 sides are equal length, then it becomes a rhombus. All right. So I hope this explanation is clear, right? Now, the area of this rhombus is given by half product of its diagonal, 2 plus Surd 3 and 3 plus Surd 48. Now you can expand one by one, but I actually prefer to simplify Surd 48. Now, of course, nowadays with this calculator, life will be a lot easier. You can actually square root and write this as 4 Surd 3. But we know that it's not too difficult to work out mentally, right? Because 48 is basically 16 times 3, which is 4 Surd 3, right? Square root 16 is 4. 3, I can't square root. I'll leave it as it is. So this is half 2 plus Surd 3 and 3 plus 4 Surd 3. Now, then you expand 1, 2, 3, 4. I'll be sure you show you're working one by one. Now, you can't be like typing in a calculator and get the answer straight away, although you can actually do that to double check, right? So this one, as we expand, you should get 2 times 3, which is 6. 2 times 4, which is 8 with a Surd 3. Then you have a 3 times Surd 3 gives us 3 Surd 3. And 4 times Surd 3 and Surd 3, which gives us another 3. Okay, so there you go. Let's simplify this. This will be half. Now what I have here is 6 plus 12. This is 6. This is 12. So that will give us 18, right? And then 8 plus 3 Surd 3. Yeah, 8 Surd 3 plus 3 Surd 3 is 11 Surd 3. Well, we have to give our answer in this form. A plus B Surd 3. So as I multiply inside, I get a 9 plus 11 over 2 Surd 3. Okay. All right, that is only the first part. Let's do part B. Now, it is given the logarithm of base AP equals this whole thing. Find the value P, and then hence find the value of log AP when A is Surd 2 over 3. Okay, now what I'll do first is I will copy my log base AP, but on the right hand side, you can see I have a half here, keep the half. I keep my log base A 48. All right. Log base A 0.25. Okay, so 0.25 is basically 1 over 4. Well, it's up to you. Maybe we can just write 1 over 4. Okay, and you can write 0.25. Doesn't matter. And then minus the 5 you bring up, log base A 3 to the power 5. Okay, now you can use a calculator and write 3 power 5. 3 power 5 is 243. Can you see that? You can choose to do that, right? I prefer to combine this. Okay, this will be log base A 48. When you plus the number, when you plus the logarithm, we multiply the number. So it's 48 times 1 over 4, divide 3 power 5. Okay, you can write 243, yeah, doesn't matter. Okay, so 48 times 1 over 4, you cancel, you get 12, right? There's a 12 here. Now 12, you can cancel with one of this. You're left with, okay, let me use another color. You're left with 4. So this is 3 power 4, right? So 3 power 4 is 81. Up to you. You can use your calculator and say this is 4 over 81. Yeah. So earlier, if you want, you can say 48 times 1 over 4, 1 over 4 here. Then you divide by 243. You can do that. Yeah, calculator can do all these things for you. 4 over 81, right? And when you bring the power half up, remember power half simply means square root. Square root of 4 is 2. Square root of 81 is 9. Again, you're not sure, you can use your calculator, square root this answer. Yeah, 2 over 9. And therefore, your P, by comparison, P is 2 over 9. Yeah, the key is to combine everything to a single logarithm. So if you can combine the right-hand side to a single logarithm, we just compare P with the number 2 over 9. Yeah. Okay, so that is the first part. The last part, very small part, yeah, was supposed to find the value of log base AP given that A is set 2 over 3. Okay, now that you know the base, A is set 2 over 3. So there are many ways you can do it. You can actually say, let log, this A here is set 2 over 3. This is P. I want to find the value of this. Now that your A is set 2 over 3, we can let it be X. Okay, so P, we know P as well, right? Yeah, your P is now 2 over 9. So maybe I put 2 over 9 straight away. Yeah, find the value of log base 2A. Okay, maybe I put P lah. All right, so P is set 2 over 3 to the power of X. Now remember, this is in logarithm form. When I write log A Y equals to X, when you change from logarithm form to index form, we say Y is A power X. So in this case, your P is set 2 over 3 to the power X. And your P is now 2 over 9. This is set 2 over 3 power X, right? Now, we know in order to get set 2, this is actually set 2. In order to go from set 2 to 2, I have to square it. So I'm going to write this as set 2 over 3 with a bracket square. All right. And by comparison, we can find out X. Our X value is just 2. Okay. So this is by changing it from logarithm form to index form. Now, alternately, some of you may want to use, may want to change the base of logarithm. You can do that as well, right? Like for example, log set 2 over 3 P. We are finding this value. We know our P is now log set 2. Okay, maybe I just write this as A, right? A first. I do it very slowly. Set 2 over 3 P. And my P is 2 over 9, right? Actually, you can use your calculator to do it. And I think this is a 1 mark question, but it's illegal to use this function in your calculator. Set 2 over 3, and this is 2 over 9. You can see that, right? This answer is going to give us 2. So we can also change the base, but I feel it's a bit long, right? You can write this as set 2 over 3. keep this as surd 2 over 3 and square. And you can bring the power down and say this is just 2. Okay, now you want to bring the power down, you can write like this, 2 log surd 2 over 3 with the surd 2 over 3. Since log AA is 1, log surd 2 over 3 with the surd 2 over 3 is 1. Answer is just 2. Yeah, so the first one is using the index method. Second one is using logarithm straight away. Okay, question number 3. Yeah, when my students set for this exam, they say, wow, this question is very difficult. They don't get it and things like that, right? Now, the first time I look at it, yes, it is a bit complicated, a bit confusing. But you read carefully, it's actually, and it's not that hard. Furthermore, they actually gave us like an equation for us to show. So that is a good guideline. So you know whether your answer is correct or wrong. Okay, so sum of 3-digit, the sum of digit of a 3-digit number x, y, z is 17, where x, y, z each represent the digit in 100, tens, and 1. Okay, so if we say the sum of digit is 17, that means the first equation will be x plus y plus z. It is 17. We call this equation number 1. Okay, then the hundredths digit. The hundredths digit is x. Okay, when we talk about 100, this is 100, this is a 10, this is your unit. Unit is 1. This is 100, 10, and unit. So this number is x, y, and z. For example, if the answer is 345, so this is 300, 3 times 100 plus 4 times 10 plus 5. That's 345, right? Okay, so they say that the 100 digit plus 2, 100 digit is x. So x plus 2, 2 times the 10 digit. 2 times the 10 digit is 2y. All right. Is more than 2 times the 1 digit by 4. So here's the thing. If I say A is a boy is taller than a girl by 10 cm. So we say the boy, the bigger one, minus the smaller one, the difference is 10, right? The boy minus the girl, the difference is 10, right? Likewise, the sum of the 100 and 2 times of the 10 is more than 2 times the ones. The ones means z, the unit, okay, by 4. So x plus 2y minus 2z equals to 4. Second equation. Yeah, sounds a bit confusing. Okay, now the next one is this. If the digit, right, if the digit in the 100 and the 1 are exchanged, right? So digit in 100 is x, digit in 1 is y, is z. So we exchange the position. All right. Okay. So you will have to put, okay, let me write here. When you exchange it, all right, z will be here, x will be here, y will be here. Okay. Now, the new number, when you exchange, the new number is 79 less than 3 times the original number. Okay. Your new number is going to be 100 times z plus 10 times y plus 1 times z. Don't have to write 1 times x. Don't need to write 1. This is a new number. All right. It is 79 less than. So it's smaller. Okay. Then 3 times the original number. Okay. 3 times the original number. Now, my original number will be 100 x, 10 y, and 1z. This is 3 times the original number. Okay. So, but this new number is smaller. This is the original number. It's smaller by 79. So you minus 79 at the back, right? So it's easier to think that way, right? So because sometimes you don't know where to plus or to minus, right? So we say this is a new number compared to the original number is smaller. It's smaller by 79. So we minus 79, yeah, 3 times the original number. Okay, and with that, we can expand and simplify this. This is 300x 30y plus 3z minus 79. Now, look at this. I'm supposed to show this. I'm supposed to start with z. Z must come first, right? Okay, so there's 100z here. I bring that 3 to the left. This 3 I bring to the left. 100 minus 3, I got 97. All right. Okay, the rest I keep to the right. Now, this x I bring to the right. Maybe I should write one more line. 300 minus 1, you get 299x. All right. I bring this to the right. You have 30 minus 10. You get 20y. And then I still have another 79. So that is my equation number 3. Yeah, I'm supposed to show this? Yes, I've got that. Okay, now find the original 3-digit number. So in this case, you're solving for x, y, z. Now, there are many ways to solve it. You can use substitution, you can use elimination. The way I look at it, since my third equation has big number and I don't want to change the third equation, right? I don't want to rearrange it. Although you can rearrange in general form like this. Okay, so what I think is I want to get rid of x and y and sub inside this equation so I can solve for z first. Okay, to get rid of x and y, if you look at equation 1 and 2, right? Equation 1 and 2, they have the same coefficient of x. So let's take equation 2 minus equation 1. So when I minus, right, x minus x disappear, 2y minus 1y, I got 1y, minus z minus 1z, you get minus 3z. Okay, so, and 4, I minus 17, I get negative 13. Let's make y as a subject, 3z minus 13. This, I'll call it equation 4. So I need to get rid of x, so I got y in terms of z. Then I also need to get rid of y, so I get x in terms of z. Okay, to get rid of y, now let's look at the number in front of y here. This is 1y, this is 2y. So maybe I take equation 1, I times 2. So 2x, 2y, 2z is now 34. Call this equation 5. Then I will take equation 5, I minus equation 2. When you minus, what happened is that equation 5, 2x minus 1x, I got x. I hope you can see. I'm referring to this and this. All right. 2y minus 2y disappear. And then 2z minus 2z, right? Minus minus is a plus. So this is a 4z, right? Okay. And 34 minus 4, I got 30. Let us make x as a subject, 30 minus 4z. This is equation number 6. Okay. So once I got this equation, I'll just sub equation 4 and 6 inside equation 3. Okay, maybe I move this a bit to the right hand side. Okay, so you can see I got more space here. All right. Okay, now, so when I sub inside, okay, let me continue here. It's easier, more space to work it out. All right. When I sub inside, I don't write x anymore. This is 97z equals 299. My x is 30 minus 4z. All right. Then I plus 20 times y, 3z minus 13. And then, oops, I plus with minus, 79. Okay, so let's expand this. Okay, I know sometimes it's a bit hard for you guys to think of it. 299 minus 30. Actually, you do think 300. 300 times 3, 900. 900 minus 3, 897. But you can't do it. You can just do like this. Okay, so it's 897, add a 0 at the back. 8970. Okay, 299 times 4. You think 300 times 4. All right, that is 1,200. You minus 4, 1196. Okay, but if you cannot just use calculator, just times 4 like this. Okay, all right, 1196. And then this will be 60z. This will be 260 minus 79. Okay, so what we have here is an equation involving z. Okay, let's do and simplify this. So I'm just going to show you calculator 8970. You minus 260, then you minus 79. You get 8631. All right. My 8631, I need to simplify this. Negative 1196 plus 60 is basically 1136. 1196 plus 60, 1136. Okay. So 1136z, bring over to the right. You're adding this with 97. So 97 minus this answer. So it's 1233. 1233z equals 8631. I know the number is very big and annoying. All right. So to find z, I take 8631, divide this answer. My z is 7. Okay, once you got the value of z, right, you can sub inside equation number, let's say we start with number 4, we find our y, 3 times 7, which is 21. 21 minus 13, your y is 8. Then you sub inside equation number 6. My x is 30 minus 4 times 7, 28. You get 30 minus 28. Your x is 2. So what is your 3-digit number? Therefore, your 3-digit number is x, y, z, 287. Okay, another thing is you can use your calculator to double check. Okay, but when you use your calculator to double check, please rearrange your equation in general form. As in the third equation here, we need to put 299x plus 20y minus 97z. This is 97z. Then you bring 79 to the other side. Okay, I'm going to show you how to use your calculator to double check. Just show you one calculator will do. If you have this calculator, press mode. You go to number 5 equation. Yeah, go to number 2. All right, key in your x, y, z. Your x is, the first equation is 1. Your y is also 1. Your z also 1. Yeah, and your number at the back is d, is 17. Second one is 1. Okay, 2 minus 2 and 4. Third one is 299, 20 minus 97, and the last one is 79. Okay, there you go. My x is 2, my y is 8, my z is 7. Yeah, use your calculator to validate or double check your answer. Okay, question number 4. So this is from progression, yeah, Form 4, chapter 5. So the second, third, and the sixth term of an arithmetic progression are the first 3 consecutive terms of a geometric progression. So find a common ratio of the geometric progression. Okay, so let's focus on the arithmetic part first. Now, we know an arithmetic progression is given as a, the general form is dn equals a plus n minus 1d. Now, they say the second term means t2. You put a, your n is 2, 2 minus 1. So you get 1d. So your second term is a plus d. And then your third term, t3 is a plus, n is 3, 3 minus 1 is 2. So it's a plus 2d. And the sixth term is t6. t6 is a plus, n is 6, 6 minus 1, 5d. So these are the first 3 terms of a geometric progression. Yeah. So if you want to write, you can write GP. My first term is a plus d. My second term is a plus 2d. My third term is a plus 5d. Now, we know in geometric progression, you must have what we call a common ratio. That means the ratio of 2 consecutive terms is a constant. In this case, if you take t2, a plus 2d, divide by t1, a plus d, the ratio is the same as t3, a plus 5d, divide by t2, a plus 2d. So what we need to do is to cross multiply and simplify this equation. So when you cross multiply, it's a plus 2d squared. And then here we have a plus d and a plus 5d. Okay. Now let us expand this. You should get a squared plus 2ab. I hope you know how to expand this quickly. 2 times a times 2d, or you can think 2 times 2d times a, that gives us 4ad, and then 2d, when you square it, you get 4d squared. As for the second one, you have to expand 1, 2, 3, 4, one by one. This will give us a square. 5ad plus 1ad is 6ad, and then 5d squared. Now, what we can do is we can cancel a square and a square. We can simplify this ad. Maybe I bring, there's a negative here. You notice I may want to bring this over. Oops, let me use a color pen. Bring the, sorry. I will bring this over, this one. I'll bring the d over. Okay, so what we have here is negative 2ad equals to 1d squared. And we know d cannot be 0. Common difference can't be 0. So we can divide it. Now, we can actually divide it. Or another way of looking at it is that, okay, perhaps I bring everything to the same side. It's easier for you to understand. Well, I will bring everything to the right instead. Yeah, bring everything to the right instead. So when I bring over to the right, 6 minus 4, I get 2. All right, 5 minus 4, I get 1. And then I factorize the d, you get 2a plus d equals 0. Now, we know d can't be 0. If your common difference is 0, the arithmetic, it doesn't progress, right? The first term will be a, second term will be a, third term will be a. It doesn't change. So my d is now minus 2a. So I've got an expression for a in terms of d. Now, you might be thinking, hey, that doesn't help me. Yeah, d in terms of a, it doesn't help me to find my common ratio. Well, we have to take this and sub inside here, right? My common ratio is basically the second term divided by the first term, right? So now that I know my d is minus 2a, so I sub in a plus 2 minus 2a, and then a plus d minus 2a. So what we have here is 1a minus 4a negative 3a. And 1a minus 2a is negative a. So when you divide, your common ratio is 3, right? Notice we don't have to find exactly what is the value of your a or the value of d, but we can find the common ratio, yeah, by doing this way, yeah, by simplifying it. All right, so that is part A. Let's move on to part B. Okay, I'm going to do part B over here. Move it a bit down here so you can see. All right, this is part B. Now, okay, perhaps I move this a little bit up because you're going to see the money. Now, Rylon wanted to save money to buy his best friend a gift worth 925. So diagram shows that he's saving for the first 3 days. So first day he has 1 ringgit. Second day he has 1, 2, 3, 4 ringgit. 1, 2, 3, 4. A bit hard to see, right? Yeah, 4 ringgit. Here he has 4 ringgit. Third day he has 1, 2, 3, 4, 5, 6, 7. Look at the number on top is easier to see. This is 7. So it goes like an arithmetic progression, right? So you want to find the amount he saved on the last day when his total saving was enough to buy the gift. Okay, so this is a case of arithmetic progression where your first term is 1, second term is 4, third term is 7. Your A is 1, common difference is 4 minus 1, which gives us 3. So what we want is the last day, the amount on the last day, but his total saving is sufficient. All right. So, but we don't know what is your N, right? We know Sn is now 925. We need to find N first. Yeah, because we know how long does it take for you to accumulate this amount of money. Now, we know the formula for Sn is for arithmetic is given by n over 2, 2a plus n minus 1d. This is the sum of the first n term of an arithmetic progression. So I'm going to sub inside n over 2, 2a, a is 1, n minus 1. My common difference d is 3. The result is 925. Now, for me, I will expand the bracket first. I mean, the bracket inside here. This is 2 plus 3n minus 3. The 2 on the left, I times it over. This number is bigger. 9 times 2 is 18. 25 times 2 is 50. 1850. Expand the bracket. Yeah, multiply this inside. Okay, so this will give us 3n squared. Now 2 minus 3 is negative 1. There's an n inside, so it's minus n, 1850. Okay, I know at this stage, a lot of people will say, just use a calculator, right? Yeah, because factorization becomes very difficult when the number is big. Well, you can use quadratic formula, or you can, if you want to experiment what I have to offer here, I would use a what we call prime factorization. First, we take the number in front, I multiply with that back, 1850 times 3, right? So 1850 times 3 is a big number. This is 5550, yeah? 5550. So I know this number, I can divide by 2. Okay, so let me show you here. I can divide by 2, right? I divide by 2. Okay, then, oh, sorry, 5550, I divide by 2. So I got 2775. Now we know obviously it's going to be able to divide by 3 because we have a 3 as a factor earlier. So I divide by 3. So I times 3, right? Okay, so I got 925. Now, obviously, I can still divide by 5, right? Right? I divide by 5, I will get 185. Then I divide by 5 some more. I get 37. Okay, there's another 5 and 37. So we just have to work out what is the combination that gives us 1. Here, I want negative 1. So I can see that this number here is 75, right? This number here multiplied together is 74. So the difference is 1, right? So then I will put double bracket. This is 3n. This is n. To get 75, I put 25. To get right. To get the second one, 74. I just put 74 here. So this will be a minus and a plus. So my n is negative 74 over 3 or 25. Now, I know a lot of students say, Terry, this is very long. Can I not do this? I don't want to use my mental effort to do this. I just press mode, 5 for equation, number 3. I key in the value 3 equals negative 1. All right, and negative 1850. There you go. I got x1 is 25. X2 is negative 74 over 3, and just work backwards, show my working for factorization. Yes, you can do that, right? You can. All right, so, but make sure you show you're working for factorization. So in this case, your n cannot be negative. We know number of terms cannot be negative, so n is 25. But we are not done yet. What are we finding? We're finding the amount he saved on the last day. We're finding T25. And your T25 is A plus n minus 124. D is still 3. So this will be 24 times 3, 72 plus 170. You can put the RM here, 73 ringgit, right? So you keep saving 1 ringgit, 4 ringgit, 7 ringgit, and keep adding until the last day on the 25th day is 73 ringgit. Yes, he has total amount of 925 ringgit, and he can buy his friend a gift. Question number 5. So this is a question from the chapter circular measure. It looks very interesting or difficult, but actually it's not that hard. Okay. Now, the first thing is you can see a diagram shows the logo of in the form of a regular heptagon, where the radius is at 5 cm. All right, center at O. To complete the logo, a black tie rope, black rope actually is needed to make the heptagon star and 3 arcs of the circle. So we're going to tie the rope, right, around the arc here, as well as the lines. There are actually 7 lines. If you observe carefully, there are 7 lines here. Let me highlight for you. 1, 2, 3, 4, 5, 6, 7. There are 7 lines. Okay, 7 lines and 3 arcs. Okay, we're going to handle that later. First thing is we need to find angle AOB. Now, if you look at AOB, AOB is this, right? Angle AOB. Now, let's recap. In Form 2, you learned this before. If I want to draw a regular pentagon, I'll have to take 360 divided by 5, which is 72. So I divide evenly at the center. Okay, sorry, my diagram is not that accurate. This is 72 each, right? So you will have to say join these together and you get a regular pentagon. If I want 5 sides, I divide by 5. If I want 6 sides, I divide by 6. if I want 7 sides, a heptagon, I have to divide by 7. But in this case, I don't want to take 360 here because you want the angle in radian, right? So I would take 2 pi. In radian, 360 degrees, 2 pi. You divide by 7. And remember, they say use 3.142. So let's use mode 3.142 pi. Pi, please use 3.142 over, 142 over 7. And I got 0.8977, right? This angle is 0.8977 radian. Okay, next, I want to, part B, I hope you can see this. Determine whether a 1 meter black rope is sufficient to make the logo. Okay, 1 meter black rope. Yeah, okay. So I don't have a lot of space here. Okay, I hope you can see. I need to calculate the length of the rope. Now, just now I've already shown you there are 7 lines and 3 arcs, right? For the length of the line, right? Let's say we focus on AOD. Let's look at AOD. Yeah? So it looks like this. This is AOD. Now, you notice this consists of 3 of AOB. Okay, I wonder whether you can see this. Maybe I rub this off. Too many lines. Look at this. This is AOB, right? This is BOC, and this is COD. It consists of 3 of this angle, right? So this angle AOD is 3 times of 0.8977. Okay. This number, 8977, I times 3, I got 2.631. 2.6931. 6931 radian. Okay. Actually, these two are equal length. We know this is a circle with radius of 5 cm. And to find the length of AD, you either use cosine rule or you can use the formula for length of chord. Now, I like chord. For those who are not sure about the idea or the formula for chord, right? It's given as this. Chord AD, in this case, it is, okay, one moment. Chord AD in this case is given as 2r sine theta over 2. All right. Now, if you're not sure about this, you can use a slow way of doing it. Slow way is like this. The whole thing is theta. Half of it is theta over 2. Let's say this is AD, and I'm going to put a T here. T for Terry is a midpoint of AD. Then I say sine theta over 2 is AT divided by your radius is R. So AT is R sine theta over 2. AD is 2 times of AT, which is 2R sine theta over 2. You can do that, right? So I like to use the formula the right way because I don't have to like derive it all the time and do one by one. So I can just use it. So your radius is 5. Your theta is 2.6931. I divide by 2. Okay, this is how it works. 2 times 5 is 10. But be careful. Your calculator must be in radian mode because this angle is in radian. So you press shift mode, change to radian, right? Sine. Take this number here, 2.6931, divide by 2, right? And my answer is 9.7496. Actually, it's safe to write 9.750. 9.750.750. Yeah, if you notice, yeah, no need such accurate answer. 9.750 is good enough. That's the length of AD. Okay, so the length of the rope, right? The length of the rope, as I said earlier, is 7 times of this length. Okay, sorry, I still need to do one thing. I need to find the length of arc AG. Yeah, AG or BG. Okay, let me do one by one. Okay, slowly. I find length of arc AG because I still need to add 3 parts of this. All right. So the radius is 5. The angle theta, we already know. Yeah, your angle theta is 0.8977. Okay, let's do one by one. 5 times 0.8977. This is 4.489. Yeah, 4.489. You want to use more decimal points, okay? right? So that is the length of arc. So the length of the rope that I need is 7 times of 9.750, 7 times of AD, right? And then 3 times of your arc, 4.489. So let's count. Okay, 7 times 9.75, and then 9.75, and then 3 times of 4.489. Oops, 4.489. There you go. 81.72. 7172. I think if you use 81.72, okay, let's see if I use small decimal point. Sometimes it might affect the answer. 9.7. Just now I got 496. This one I got 4.488 something. Let me see again. 5 times 0.8977. Okay. Yeah, 4885. Okay. So if you use more decimal point, 7 times point, this is 9.7496 plus 3 times 4.4885. Okay, I got 71. Yeah, 81.71. Yeah, so if you use more decimal point, you get 81.71. Yeah, but I think it's good enough because this is already for SF every step of the way is good enough. Yeah, but if you want more accurate answer, use 5 significant figure here, 5 significant figure here, then your final answer will be 81.71. Okay, lastly, I want to know the last part, part C. Calculate the area. They say segment AG, BC, DE will be painted with yellow paint. Calculate the area to be painted. Okay, the area to be painted is the, as you can see, the yellow part here. Okay, I think I'll just leave it like this. Okay, I need to find this area here. So, and then I times 3. Now, area of segment, I hope you already know the formula for area of segment. Yeah, formula for area of segment is given by half r squared theta minus sine theta. Okay, so for those who are not sure about this, it's actually an area of sector minus area of triangle. Your sector has a radius of r, angle theta. Your triangle is actually in the form of half AB sine C. Yeah, let me show you here, half r squared theta. You know, in the chapter solution triangle, you learn from 4, you learn about this, right? AB will be r and r, sine of the angle in between theta. If you factorize it, you get theta minus sine theta. Now, I prefer to use this because it is a lot faster. All right. Now, my radius is 5. I square it. My theta is now 0.8977, right? From the earlier part, AOB. So, I minus sine of this angle. Okay. So, let's count. Half 5 squared, 0.8977 minus sine 0.8977. All right. I got 1.4476. Yeah. 1.4476. Actually, you can do directly. Yeah. So the area, this area segment, this is the area to be painted. It is actually 3 times of this value, right? 3 times of this value. You can just times 3. I think it's more than enough. The accuracy is 4.343. 4.343 square cm. Okay. Okay, question number 6. This is from the chapter integration, from 5, chapter 3. Okay, diagram 4 shows two curves y equals x squared and y equals negative x squared plus 4. They intersect each other at point A. Your equation of AB, AB is parallel to y-axis. Parallel to y-axis means it's a vertical line. So the equation should be x equals to a number. You're supposed to find equation of straight line AB. Okay, so the first thing is, number 1, I think we can just let y equals x squared to be your equation number 1, and y equals to negative x squared plus 4 as your equation number 2, as I sub 1 in 2, right? So your x squared equals to negative x squared plus 4. Bring it over, 2x squared is now 4. X squared is 2. X is square root 2. Now, you don't have to put plus minus because this x is on the right-hand side of the y-axis. So x is more than 0. Your equation is x equals Surd2. It's an equation of a vertical line. It's always x equals a number. In this case, is x equals to Surd2. Okay, next, area of the shaded region. Yeah. Now, your shaded region is actually bounded by this. This is a curve. It is given by the equation y equals x squared. And the second curve, maybe I highlight here. Yeah. When it's given by this y equals negative x squared plus 4. So when you integrate respect to x, the graph is bounded, the area is bounded by the x-axis. So we have to integrate y dx. So your area consists of two parts. The first part, 0 to Surd2, because this x value is Surd2. All right. The curve is x squared dx. The second part, you have to integrate from Surd2 to this number. Okay, here's the thing. I don't know what is this number. You might have to find it separately. Yeah? So this is actually your x-intercept. Now, we know from equation 2, can we say from this equation, right? At x-axis, your y is 0. All right, this is from equation number 2. So 0 equals negative x squared plus 4. X squared is 4x is plus minus 2. But we don't have to put plus minus 2 again because we are looking for the value on the right-hand side. Yeah, so x should be 2. Yeah, we integrate from Surd2 to 2. And this function is negative x squared plus 4 dx. Okay, the first part, when I integrate x squared, I increase the power by 1. I get 3 over 3, lower limit 0, upper limit Surd2. As for the second one, when I integrate this x cubed over 3, integrate 4, we get 4x, lower limit Surd2, upper limit 2. Now let's substitute 2 inside. Now, Surd2, if you cube it, right? Now, there's one shortcut. You can use your calculator if you want. Surd2 square is actually square root 8, cube is not square, it's cube, sorry. Is actually cube root, square root of 8 or 2 Surd2. Right? You can do it directly at one shot, or 2 Surd2, right? If you're not sure, I can show you here. Surd2 power 3 is basically Surd2 power 2 plus 1, which is Surd2 squared times Surd2 or 2 Surd2. We can think this way, right? So this is 2 Surd2 over 3, you minus 0. Now, likewise, when I sub 2 inside, this one is 8 first, 8 over 3 plus 4 times 2. This is a minus with the okay, let me put a round bracket. Surd2, 2 Surd2 over 3 plus 4 times Surd2. Okay, now notice the minus becomes a plus here. Or maybe I simplify this further. There's too many things to simplify, right? So let us just do one by one. This will be 8 times 3, 16. 16 minus 8 is now so 8 times 3 is 24. 24 minus 8 is 16. So this is 16 over 3. Then there's a 8. 4 times 3 is 4 times 3 here. 12. 12 minus 2 is 10. Minus a plus. So it's a plus 10 Surd2 over 3. Okay. So it's very long, right? I need to simplify this. There is a, this is a minus a 12 minus 2. Sorry, this is a 10. There is a mistake here. I'm trying to find out 12, 10 minus plus. This is a 10, a minus. Sorry, there's a negative here. There's a negative here. Okay, so I made a mistake. This is a minus here. So when you subtract, you get 16 over 3 minus 8 Surd2 over 3. Well, we can stop here, or you can factorize if you want, but it's actually not necessary. Like some student may say, oh, why don't we put 8 over 3 to minus 2? Yeah, you can. It's the same thing. All right, now let's double check with our calculator. So sometimes we're not sure whether our answer is correct. So I'll integrate the first part. This will be alpha x squared. Lower limit is 0, upper limit is Surd2. Okay, so this answer is, the problem is sometimes we don't know whether, the calculator cannot give us in exact form. So it's in decimal form. So it's okay. I think I will just show you how to do it one shot. Then we use a calculator. We use decimal to validate. Okay. There is an integration of minus alpha x squared plus 4. Lower limit is 2. Upper limit is 2. So this is 1.562. Okay, 1.562. Let's double check whether my answer is the same. 16 minus 2 with an 8 outside, divide by 3. Yeah, 1.562. So I know my answer is correct. Okay. All right. So that is the second part, B, the area. Now let's move on to volume. Okay. Now the volume that you're finding is volume of integration when the region bounded by the curve y equals x squared and y equals negative x squared plus 4 is rotated 180 degree about the y-axis. Okay, so when you talk about 180 degree rotation, remember, if you have, let's say, for example, the curve is like this. I only have one side. How many degree do I need to rotate to get a complete solid? Well, answer is 360. So, but as you view from here, whether you view from down or top, doesn't matter. I just show you one example here. So when you view from here, what you see is one thin line. So I need a 360 degree rotation to get a complete solid. But let's say the area that I have is double. Yeah, and since they're symmetrical, so when you view from here, what you see is double the thickness, right? So when I rotate 180, this point will end up here. This point will end up here. So this point over here, you end up on the left. The point on the left, we end up on the right. So we're actually getting the same solid. Yeah. So when you have the area that's symmetrical, yeah, and it's double, you only need 180 degree rotation to get the complete solid. You don't need 360 degree, right? Okay. So don't worry about putting a half in front because it's half the it's half the volume. No, it's not true. Right? It's the same volume that we are talking about. Okay. Now let's look at this case now. So area bounded by the curve. So let me rub this off. Okay, and I highlight the first curve. The first curve is y equals x squared. Let me just highlight over here. This is the first curve, right? And the second curve is negative x squared plus 4. Second curve. Okay, so area bounded by these two curves. So the area in between them is this part, the green part. All right. And when I rotate 180 degrees, you can see it's double. Yeah. So this will go to the right. The other side will go to the left. So I'm actually getting the same solid. Okay. Another good news I have for you is that you can see they're actually symmetrical. As in, when you draw a line, let me draw, what color should I use? Say purple. When I draw a line here, you notice they are actually symmetrical because y equals x squared and y equals negative x squared plus 4. They are actually, these two curves, they are actually symmetrical in the middle here and the point of intersection. Well, this point of intersection, we know this is 4, this one is 0, this is 2. At y equals 2, they are symmetrical. So you can actually find volume of one of them and then you just times 2. That will make your life easier, right? You just find perhaps the yellow part here. Yeah, oh, you can't see, it looks the same, maybe blue. Okay, wait. I would use blue, but okay, maybe a darker color, cannot see, right? Yeah, okay, this color, okay. I'm going to take this and I'm going to double it, right? So take this volume times 2, I get the whole volume of solid, yeah, that I'm looking for. Okay, so let's just get back to this. Let me just move it down a little bit. Okay, I'm going to find the volume by using part C here, integration pi y square, x square dy, because I'm rotating about the y-axis. Now we know your lower limit is 0, upper limit is 2, and this volume, you can choose to do one by one, but I think I prefer to times 2. Like I said, they are identical, so you don't have to do one by one, you just times 2. That's why I put a 2 pi in front. Okay, remember your y equals x squared. So if you want to integrate, right? You need to make x squared subject. In this case, x squared is y. Let us sub inside 0 to 2. This is y dy. As I integrate this, I will get y squared over 2, lower limit 0, upper limit 2. We can cancel this 2. Cancel 2 and 2. Put 2 inside, you get 4. There's a pi outside, minus 0. Answer is 4 pi. Yeah, it's a lot shorter. But again, some people say, oh, I don't quite understand this. I want to do one by one. So the first one is x squared, which is y dy. The second one you can do from 2 to 4. If you have y equals to, from here, if you bring over, you get x squared equals to 4 minus y. So this will be a 4 minus y with a pi outside dy. This will be pi y squared over 2, 0 to 2. This one I like to use composite function. I copy the bracket, increase the power by 1, divide by the increased power, and differentiate inside from 2 to 4. Let us put 2 inside. 2 squared is 4. 4 divided by 2 is 2. This one is 0. If you want, okay, I show you more step. This will be 2 minus 0. This will be pi over negative 2. I take out the negative 2. Put 4 inside. 4 minus 4, 0. 4 minus 2 is 2. 2 squared is 4. I just write 4 straight away. So this is now 2 pi plus 2 pi, which is also 4 pi. Yeah? So you don't have to do that because they are symmetrical. Yeah, they're identical. We just flip it up, right? They're the same thing. So I just find one of this volume, I times 2 to get the same solid. All right. Okay, moving on to question number 7. This is from the chapter Trigonometry. So, trigonometric function from 5, chapter 6. The first thing we need to do for the first part is to show that this 2 cotangent minus tangent over secant cosecant equals to 2 cos 2x. Okay, we're going to start off with the left-hand side. We always start off with a side with more number of terms. In this case, your left-hand side. Now, in trigonometry, if you see cotangent, cosecant, tangent, secant, and so on, basically you can change everything to sine and cos. It's easier to change to sine and cos. And we know cotangent is cos over sine. All right, cos over sine. And tangent is sine over cos. As for your secant and cosecant, secant is 1 over cos. Cosecant is 1 over sine. Now, the easiest thing to do is to multiply everybody by sine and cos. But I know a lot of people, if I do it one shot, they find it's a bit hard to see. So what I'll do is I cross multiply first. I do a bit slower. I basically combine this as a single, these two as a single fraction. And we take cos multiplied by cos. You get a cos square here minus sine square. Sine multiplied by sine. This is, show you this way. Yeah, and then you multiply sine and cos together, you get sine x cos x. As for your denominator, this is sine x cos x. As for your denominator, you have 1 over cosine. Cosine, sine, cos, they are basically the same. We can just cancel them off, and you're left with 2 cos square minus sine square. And we know cos square minus sine square is just cos 2x. Cos 2x has 3 formulas. This is the first one. So this is cos 2x. There you go. That's your right-hand side. Okay. Now, next, we're going to sketch a graph. Okay. Sketch this graph. Now, look at part B. The entire thing here is actually the same as the one above. See? So, basically, we are sketching the graph of y equals 2 cos 2x. Now, I hope you know by now, the 2 in front of cos means it's amplitude. The basic graph of cos, if you still remember, the basic cos graph looks like this. Amplitude is 1, meaning maximum 1, minimum -1. When you have a 2 in front, it simply means we stretch up by 2, maximum 2, minimum -2. And 2 cos 2x simply means we draw 2 complete cycle, 1 cycle, 2 cycle from 0 to 2 pi. Okay, so let's draw a bigger version. I draw a bigger version for you. It looks like this. Maximum 2, minimum -2. Okay, maybe I subdivide into 8 parts. All right, so it's easier. And to ensure that you draw a nicer looking graph, you may want to put the point here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 2 pi. This will be pi. This is pi over 2, 3 pi over 2. Now, you don't have to divide every single thing. You don't have to label every single thing. Maybe we just draw 4. Yeah, 4 important segments will do. And maybe use a slightly thicker pen, right? That will help you to cover up the ugliness, right? Draw using a thicker pen. For you guys, use 2B pencil, right? It will look a lot nicer with a thicker pen. Yep. So this is my first graph. Then one more time. Second graph. Right? Oh, this is a masterpiece. Right. Now, the next thing is this. I've drawn my graph. Okay. They say determine the range of number of solution n for this equation equals to p, where p is the number between -2 and 2. Okay, I like this question. It's very interesting because most of the time they ask you to find the number of solution. Here they ask you to find the range of number of solution. Now, you notice this entire thing is the same as the one above. So this is B Roman 1. Okay, let me do B Roman 2 here. So we know the entire thing is now your 2 cos 2x and it's now P. So this equation can be solved by drawing 2 graphs. The first graph is y equals to cos 2p, which is what we have already. The second graph is y equals to p. Now, y equals p is a horizontal line, right? Horizontal line. The question already mentioned that it's supposed to be between p values between -2 and 2. That means your p can be here. Let me draw a horizontal line. Okay, again, let me use a different color pen and maybe a thicker pen. Okay, a thicker pen. Okay, so let's say I use red color. Now, when I draw it here, you notice you will have 2 solutions. Yeah, exactly 2 solutions. If I draw it here, I will have 4 solutions. If I draw it here, I will have 3 solutions. So meaning your y equals to p, right, can be anywhere between -2 and 2, right? Can be here, or here. And from the graph, right, your number of solution n can be 2, can be 4, or it can be 3, right? It's 2, 3, or 4. So the range of values of n, so you have to write the range as n between 2 and 4. Yeah, very interesting question. Now, it's not necessary for you to draw that horizontal line, but I just draw it for you to help you understand that this one has 2 solutions, this one has 4 solutions. If you draw this a bit higher or lower, anything between -2 and 2 doesn't matter. You can see it's always 4 solutions. And if you draw at 2 itself, you see that it's always 3 solutions. Yeah, so your range of values of n is 2 to 4. Okay, now it's time for some infomercial. So here we have our Shopee site, Pusat Tuition Teliti. You can find us on Shopee here. And this is where we have offer books across all syllabus, A-levels, IGCSE, SPM, PD3, and so forth. Yeah, this is here. I'm explaining the videos, the books and videos that we have. All right. And we have a range of SPM past year question, drill practice, topical practice, right? And also we have notes and tutorial series with basically is tuition class across the whole year, right? With books provided, right? So if you don't like Shopee, you prefer Lazada, we have Lazada as well, right? You can actually find us on in Lazada as well, where we have a range of books available for you for additional practice. Okay, moving on to section B, question number 8. So here we have a box that contains 2 types of sweets, A and B, in the ratio of 1:2. All right, 5 sweets are chosen random with replacement. Now remember, when you draw, you put back, you draw again. It's a binomial distribution. The probability is fixed, is constant, right? So we can use the binomial distribution formula, which is Bx equals to R NCR P power R Q power N minus R. So the first part here, we want to find exactly four types. Four type B suites are chosen. Okay, type A and B, the suites are in this ratio 1:2. That means the probability of getting type B, maybe I write in this form. Although it's not necessary for you to write this. This is a notation. X follows a binomial distribution. Your N is 5 because I'm choosing 5 suites at one time. Your P is probability of getting suite type B, so it's 2/3. So now we want to find exactly 4 type B. So in this case, we write 5 choose 4. P is 2/3 power 4. Remember, Q is 1 minus P. If your P is 2/3, 1 minus 2/3 is 1/3. 5 minus 4 is 1. Okay, now you can use your calculator this way. Type 5 choose 4 times 2/3 power 4, then you multiply with 1/3. Okay, my answer is 80/243. Right, let me write here 80/243, or you can choose to change it to decimal. That will be, well, big number, 0.3292. Yeah, 0.3292. 4 decimal place is good enough. 4 significant figure is good enough. Now, for those who have this calculator, the class width calculator is so much better. You can just key in your N, your X, you get the answer. But first, we type in mode, press 7. This is 7 for distribution. Press 4 for binomial PD. You go to 2 for variable. Your X value is 4. Your N value is 5. Your P value is 2/3. There you go. 0.3292. Yeah, you're getting the same answer, or 80/243. Okay, second part. Now, notice part A, we are interested in getting type B. Part B, we're interested in getting type A. So in this case, your probability is now different. Yeah, although your N remains the same as 5, but your probability of getting type A is 1/3. And you want more than 2. More than 2 in this case means 3, 4, or 5. 3, 4, 5. Okay, so let's just list out one by one. Okay, 3, in this case is 5 C3. P is 1/3 power 3. Q is 2/3 power 2. 5 minus 3 is 2. This number is N minus R. Then we add 5 choose 4. 1/3 power 4. 2/3 power 1. And 5 choose 5. 1/3 power 5. 2/3 power 0. Okay, I have 2 different ways to calculate. One by using this calculator. All right, now notice we can use the summation formula for this calculator. We press Shift Log, that gives us a sum. I type a general formula 5C. Instead of using a number, I use X. Yeah, X is alpha X here. You multiply with your probability is 1/3 power X, alpha X. Then you multiply with 2/3 power N minus X. My N is 5. You minus alpha X. Okay. Then I go down and move down to this sum. We start from 3. We end up at 5. So there you go. I got 17/81. Or if you change to decimal, it's 0.2099. Yeah, 17/81 or 0.2099. Okay, if you want to use this calculator, you can do the same. And this calculator, there are various functions you can use. 2 functions you can use. And one, you stick back to PD. Okay, you go to number mode 7. Yeah, show you again. Mode, sorry, we say menu 7 for distribution. Go to number 4, binomial PD. Go to list. Listing means we list out the number that we want. We want 3, we want 4, we want 5, right? So just press equals. My n is still 5. My p is not 5 now, not 2 over 3, it's 1 over 3. And I press equals. There you go. The only thing is I have to add them up. Yeah, so you may have to write it down into like, okay, take a calculator, type it out, 1.1646. All right, then you add plus 0.04115. Okay, I'll just write this. Okay, then you plus, this is a very small number, 0.000041. Okay, doesn't matter, 4115, 41 will do. Can you see your answer is still the same, 0.2099, right? You can do that, or we can use the cumulative density. You press mode, you go to 7, you move down, binomial CD. Binomial CD simply means you add up to, right? Like for example, if I want more than 2, you need to think 1 minus up to 2. Up to 2 means less equals to 2, right? Because we want 3, 4, 5. I take 1 minus 0, 1, 2. So when you use this function in your calculator, this calculator here, all right, what we need is to go to number 1, binomial CD, go to variable 2. I want up to 2, right? So my x is 2, my n is still 5, my p is still 1 over 3. This is my probability. But I need to do 1 minus answer. Okay, 1 minus 0.7901. Okay, let me just do separately 0.7901. Okay, maybe I should just show you on this calculator here. Yeah, 1 minus 0.7901. Guess what? You got the same answer, 2099. Okay, so there are many ways you can calculate this. All right, that is the first part, binomial. Second part is a normal distribution. Okay, so now the length of a type of insect normally distributed, mean of 2 cm, variance of 0.09. Be careful, this is variance, not standard deviation. Okay, let me write down. Mean is 2, variance is 0.09. Your standard deviation is the square root of your variance, which is 0.3. Yeah, 0.3, 1 decimal point. Okay, you're supposed to find the percentage of insect with length more than 2.28. Okay, so we need to standardize. I remember from x to z, we have to take your x value minus your mu, which is 2, standard deviation 0.3. Okay, so let's count. This will be 2.28 minus 2 divide 0.3. Okay, I got 0.933. Okay, so normally I would take I'll take 3 decimal places. Yeah, because your mathematical table can read up to 3 decimal places here. But I wouldn't use the mathematical table to calculate this because it's very slow. I'll use this calculator for, there are 2 calculator model you can use. I can use this and this. So let me start with the silver one. Okay, the silver one, I will press mode. You go to number 3 for stats. All right, just press AC. Yeah, as long as in stats mode, we can use this. All right, and then from here, you press shift 1 for distribution, right? Stats of distribution. Press 5. Okay, and then from here, you want to press 3 for R. Remember, R in this calculator here means upper tail. Yeah, so we press 0.933 and press equals. I got 0.1754. 0.1754. So your percentage, if you're finding percentage, basically you just multiply by 100, 17.54%. Okay, for those who are using this calculator, same thing, you press mode, press 7. All right, but in this case, you need to choose number 2 for normal CD. Press number 2 for normal CD. All right, and my lower, if you are using from here, right, if you're reading from here, my lower tail would be 0.933. My upper tail will be infinity. It goes all the way to infinity. You just put 999, doesn't matter. Standard deviation is 1. My mean is also 1. There's a mean here. There's a mean here. Mean mean is 0, sorry. Then you press equals, there you go, 1754. But the advantage of this calculator is that you can even change to the amount, or should I say X, what do you call that? Non-standard normal distribution. Z is a standard normal distribution. Z has a mean of 0, standard deviation of 1. But X is a non-standard normal distribution. So if I use 2.28 and upper tail is 999, I can set my mean to be 2, right? Here, mean is 2. And I can set my standard deviation to be, my standard deviation is 0.3. Yeah? Standard deviation is sigma. My mean is 2. Guess what? I get the same answer. 17. But notice that sometimes there's a slight difference. 1753. Actually, this answer is more accurate because we actually rounded off at this stage. When you round off correct to 3 decimal places, right? That's a problem, right? It's not as accurate. Okay, moving on to the second part. Here they say find the value of m if 15% of the insect have length less than m. So, okay, maybe I do it over here, easier to see. 15% have length less than m. 15% means 0.15. So here we have to standardize it. The moment you standardize, this is m minus mean over standard deviation, 0.15. The thing is, we need to find out what is your z value from the probability value. So let me do a sketch. It's very important that you sketch a correct side. All right. Now, where do you fix your m minus 2 over 0.3? Okay. Where you fix depends on two things. Number one, the sign here, the symbol here, whether it's more than or less than. Number two is your probability, whether it's more than half or less than half. Now, for beginners, sometimes you do this, you don't know where to put. It's okay. We can change it. Yeah. The step is, number one, you fix the position, right? Number two, you shade the region. Number three, you check whether it makes sense or not, right? For example, let's say I'm not sure where is m minus 2 over 0.3. I fix on the right-hand side. So I put m minus 2 over 0.3. Then to shade the region, I need to look at my symbol here. Less than means I shade to the left. So this is on the left. Okay. The next question to ask yourself is, can this area be 0.15? Answer is no. It can't be on the left. It has to be on the, your area cannot be on the left. I mean, this part here, the z value cannot be on the right. It must be on the left, right? If it's on the right, then the area is more than 0.15. Cannot be 0.15. 0.15 is less than half. Okay, so I know I had to fix this on the left instead. So this is m minus 2 over 0.3. Less than, the region is over here. All right, I know this area can be 0.15. It makes sense. Okay, the next question is, how do I read this 0.15 thing? Okay, so reading backwards, right? This calculator, I'm sorry, is helpless. It cannot do anything, right? So we either use a mathematical table or we use this black calculator, the class width calculator. Okay, 0.15, let's say I don't have the black calculator. I need to use this table. You have to slowly find one by one. That is the annoying part. Where do I find this 0.15? Okay, so my 0.15, you need to find a number slightly more than 0.15, which is this. Can you see? Slightly more, right? Then I need to subtract 15 from the last digit. So you move across, look for 15. I don't have 15, I have 14 or 16. You choose one. It's okay, right? Both are also fine. Okay, so this is 1.03, and you need to subtract. When you subtract 14 from the last digit, I actually get 0.1501, which is close enough. All right, you can subtract 16, but for the top part, you have to add. So you read this as 1.036. 1.036. Okay. Right, so I go back to this and write, I know that this one, when I read z more than 1.036, I get 0.15. Now, the problem is, this is on the left, so I cannot, it's not the same. This is m minus 3 over 0. M minus 2 over 0.3 is not 1.036. But we know the symmetrical property of normal distribution graph. If this is 1.036, this is 0.15. I can actually flip it to the left and write this as negative 1.036 because a normal distribution, the standard normal distribution graph is symmetrical at the center at 0. So this is still 0.15. So what I can do instead is to take m minus 2 over 0.3 and equate this with negative 1.036. Okay, I know some people say, wow, this table is very difficult. I don't want to use this. Well, invest in this calculator, right? So this calculator, as you press mode 7, you go to number 3, inverse normal. All right, your area in this case is 0.15. Now, let's say I just use the standard normal distribution. A standard normal distribution, your standard deviation is 1, your mean is 0, okay? And you get negative 1.036 straight away. Now, the thing is that this calculator is meant to measure the area from the left. So, yeah, sometimes you may get answer from the right, but doesn't matter. So this is 0.15. This is negative 1.036. The calculator will read from the left, all right? So if let's say your problem, you want it on the right-hand side, then you got to flip it over and just drop the negative sign. Okay, now with that, we can just multiply this over. Okay, I'm going to change this to computation mode. Just multiply over. This is negative 1.036. I multiply with 0.3, then I plus with 2. My m is 1.689. Yeah, 1.689. Now, the advantage of using this calculator is that you can even set your mean and standard deviation. Like your standard deviation is 0.3. Your mean is 2. There you go, 1.689. I got straight away. Yeah, you can do that. Okay, so again, I hope you know this. You can just multiply over, then you bring the 2 over. If you want me to show you more step, it looks like this: 2 minus 1.036 times 0.3. I got this answer, 1.689. Okay, moving on to question number 9. So here we have a question on linear law, Form 4, Chapter 6. Table shows the values of two variables, x and y, related, obtained by an experiment. They are related by this equation, y equals to, let me just highlight for you, y equals to 16 over p squared with a bracket x minus q squared. So we're supposed to plot square root y against x, right? They give us a scale here. Now, number one, you need to recalculate your square root y. X, we don't have to do anything. So now let me write my square root y over here. We have to use a calculator. The first y value, let me just move it over here, 0.8281. This will give us 0.91. Yep, 0.91. Second one, we'll take square root of 2.85, square root 2.8561. This will give us 1.69. Okay, 1.69. The next one, 6.25. If you square it, I think it's 2.5, right? But never mind, I'll just show you here. 2.5. Maybe I use one more decimal point, 2.50. Then the next one, I'll take square root 10.89. I will get 3.3. This is 3.3, 3.30. Okay, the next one, number 5, I take square root 16.81. This will give us 4.10, 4.10. Okay, and lastly, square root of 23.52, 23.52. There you go. You will get 4.85. Yeah, 4.85. Okay, so one thing I don't know whether you know, you watch my previous video for other state paper. I've always would prefer to find the gradient y-intercept from my calculator. Okay, so if you're using this calculator, right, we can change the mode to statistic. We go to number 2, a plus bx, right? That's your x and y value. You key in on your x value, 1, 2, 3, 4. It's quite easy. 5, 6. There are 6 points. Okay, and then you move on to your y value. The first one is 0.91, second one 1.69, oops, 1.69, third point is 2.5, next 3.3, next 4.1, and last one 4.85, 4.85. Okay, so once I key in all my x and y value, go AC here, press Shift 1 for stats. Go to number 5, regression. All right, and press 1 for A. A represent your y-intercept, and my y-intercept is 0.12, right? 0.1186, 0.12. So in this case, I know my y-intercept is 0.12. You might get slightly more, slightly less, but doesn't matter, around there, 0.118. So if you want to find your y-intercept, your gradient, Shift 1, press 5 for regression again, press 2 for B, press equals. This is your gradient, 0.79. Yeah, my gradient is approximately 0.79. Okay, so let's begin. We start plotting the graph now, knowing that our gradient y-intercept should be these two values. All right, so I think we can take your x-axis. It is given here 2 cm for 0.5 for y-axis, 2 cm for 1 unit for x-axis. So this is 1, 2, 3, 4, 5, 6. My largest x value is just 6. Okay, for y value 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5. Let's keep going. 5.0. Okay, and this is square root of y. Maybe I should just add in my axis, makes it look nicer. I add in here, this is my horizontal axis. Okay, add in my vertical axis. Oops. My vertical axis is from here up. All right, let me just adjust it a little bit. All right. Okay, this is a bit to the left. Just adjust it a bit to the, make it a bit more center here. You can see is, there you go. All right, so I've got my axis done. Now let's plot 0.91. 0.91 should be here. Let me just zoom in a bit small to see. So zoom in a bit here. 0.91, the first one. 0.91 is over here. 2 is 1.69 or 1.7. You can read 1.7 is over here, 1.7. Okay, sorry, this is 1.8 actually. 1.7 should be a bit lower. 1, 2. One more lower here. All right. Up, hold on, right. So sometimes a bit hard to see, a bit, yeah, this is correct. Next one is 2.5, 3 and 2.5. This is okay on the dot here. All right, maybe a bit more to the left. Right, 4 and 3.3. 3.3 is approximately 3.0 is here. 3.3, a bit higher. Or still a bit hard to see because my line, yeah, okay. When I zoom in, a bit easier to see. This is 3.3. Yep. Next one is 5 and 4.1. 5 and 4.1. And 6 and 4.85. 6 and 4.85. So it's here, right? Now remember, one small box is 0.5. Yeah, so I moved down 3 small boxes because, yeah, you need to minus 0.15 from 5. Okay, so I've got the points all done. Next, we need to plot the line of best fit. Okay, so use a ruler, right? I have to use this line tool here. So now we know my y-intercept is approximately 0.1, 0.12 around. You can even use 0.15. Okay, now the good news is when you know your gradient y-intercept in advance, we can actually detect if I make any mistake, any points are wrong, plotted wrongly. As you can see here, I detected my one mistake here. My y-intercept supposed to be, when the x is 1, supposed to be 0.9, right? Just now it's a bit lower, right? So I actually see one mistake here. This one is approximately 0. Now you can take 0.125. Actually, it looks like in between 0.1 and 0.15. So yeah, I think it's okay to even take 0.125 because I know my answer is 0.12. That's the most accurate answer, right? You can use 0. You can take 0. 1 or 0.15, or in this case 0.125. Okay, but I think we still need to do some adjustment. You can see my 3 points are above, so let me adjust this a little bit, right? Move this up a little bit to here. See, this is a little bit better. Okay, see whether it passes through all the points or not. Now I can see one point is below. The second point is below. The third point, maybe I should just move it down a little bit. Just down a little bit. One more time. Okay. Right. Slightly below. Doesn't make a lot of difference, but it's probably a little bit better. Okay, a little bit better. Yeah, I think we can use this. Okay. All right. This point is also a little bit lower. Okay, now remember two things we need from the graph: gradient, y-intercept. So if you want to read your your gradient, you find your gradient, right? We need to take 2 points and measure, find the gradient. So for me, I'd like to take smallest 0, largest I take 5 boxes. Why 5 boxes? Any number divided by 5 is a round number. It's a nice number. It's a terminating decimal, no recurring decimal. So I'm going to take this coordinate here. Now notice that I don't take the point from the table, because this point here, you see, the line of best fit doesn't pass through the point. It's actually 5, and it looks like 4.125. Yeah, 4.075. Or should I use 4.125? Yeah, 4.1. Maybe I should use 4.1. Yeah, 4.1. Looks a bit like 4.1. Okay, 5, 4.1. It's okay. So 5 and 4.1. Okay, so right. So now let's go back to your question. I need to find my gradient and y-intercept. Okay, so I think you can see, right? Zoom in a bit. Move this up a little bit. Okay. All right. So let's look at this is B Roman 1. I plot my graph already. Let's find a gradient. My gradient, I take 4.1 minus 0.125, divide 5 minus 0. Like I say, why use 5 boxes? Because any number divided by 5 is a nice number. So in this case, let's find the gradient by taking 4.1. Oops, change my calculator to normal mode first. 4.1 minus 0.125, divide 5 minus 0. Okay, my gradient is 0.795. 0.795. I think this is the closest I can get, because my answer is my gradient is 0.79. I got 795, very close. My y-intercept is 0.12. I got 0.125. That's super close already. Yeah, but if you get 0.1 or 0.15 for the y-intercept, I think it's fine. Okay, next I want to find the value of P and Q. Okay, now the value P and Q you can find from this original equation, and we convert to linear form. Okay, let me just write down my y-intercept 0.125. Okay, so let us take my y here. Starting from this equation, I'm going to square root both sides. Square root my y, square root 16, I get 4. Square root p square, I get p. Square root x minus q square, I'm left with x minus q. Yeah, the square here disappears. Okay, so next, multiply inside 4 over px minus 4q over p. So this is your big Y, this is your gradient, this is your X, and this is your C. Now I need to compare my gradient that I've got from my graph here and the gradient that I got from my equation here when I convert to linear form. So here I have 4 over P equals 0.795. Bring the P up, bring the 0.795 down. 4 divided by answer, yep, I got 5.031. Yeah, 5.031, which is very close, right? Some of you may get 5, it's fine. If you get your gradient as 0.8, it's okay. 0.79 is still okay, right? Now, for your y-intercept, we know if you compare from the graph, I got 0.125. From the equation here is this, right? There is a negative here. So this is comparing gradient. This is comparing y-intercept. Negative 4q over p. So since my p is 5.031, I'm going to sub inside This is 0.125. I want to find my Q. Let's multiply over 0.125. I multiply with 5.031 and I divide by -4. My answer is, not a nice number, -0.1572. Yeah, it is negative, -0.1572. Okay, I got my P, I got my Q. Next, find the value of Y when X is 1.7. Okay, 1.7 is about here. Okay, let me zoom in a bit, hard to see. 1.7, a little bit more to the left here, 1.7, move it up. This is 1.7. I'm going to find my Y value. My Y value, it looks like in between, or no, 1.45. Okay, 1.4, I will take 1.45. 1.45. Okay, all right, this is my square root Y value. Okay, so, okay, from here, from the graph, this is Roman 2. From the graph, when X is 1.7, your square root Y is 1.45. Use your calculator, 1.45, you square it, I got 2.013, 2.103, sorry, 2.103. Might get a slightly different answer, but that's right, okay? All right. Okay, moving on to question number 10. So here we are finding the, this is quite a question related to coordinate geometry, Form 4, Chapter 7. You're given a rectangle here, KLMN, with the coordinates are given, right? You're supposed to find the value of P. Now, notice the first thing about rectangle. Rectangle is actually a family of parallelogram. That is the midpoint of the diagonal. Let me draw the diagonal. Yeah, they must be the same. The midpoint of the diagonal is in the middle here. Yeah, midpoint of KM must equals to LN. So I need to find the coordinate point P. So here I'm going to use midpoint here. Midpoint of KM equals midpoint of LN. Okay, so now for KM, we have -10 plus 8 over 2. And this is Q plus 2 over 2. And for Ln, we use P plus 2 over 2 minus 7 plus 10 over 2. Now, since we are only finding P, we just compare our x coordinate. So my x coordinate here is -2. And in fact, I'm just comparing the numerator. I don't need the denominator. So -2 is now P plus 2. P is -4. Now, you don't have to find Q here. So I'm not finding Q for now. We just had to find the value of P. The next thing is we're going to find equation of straight line KL. Well, you can see KL here is parallel to NM. When two lines are parallel, we know the gradient must be the same. So let's find the gradient of NM since I know coordinate point M, N, and M. So I'm going to use 10 minus 2 over 2 minus 8. So this is 8 over 6, which is 4 over 3. But there's a negative in front. -2 minus 8 is -6. -8 over 6 is -4 over 3. Now, then, since they're parallel, they must have the same gradient. So to form equation of straight line KL, since I know point L, I know P. P is -4. So this coordinate is -4 minus 7. So I'm going to use Y minus Y1. My Y1 is -7. Gradient is -4 over 3. X minus X1. X1 is -4. So -4, we write +4. So let's multiply over. This will be 3y plus 21 equals -4x minus 16. Let us bring this over. 3y is -4x minus 37. Now you can write in any form if you want, but here the question never specified to write in general form or gradient form. So I can actually leave it like this. Okay, then they say Find also the value of Q. So actually, we can find Q by using midpoint earlier, but since they asked us to form equation on straight line first, right? Then you find Q, we can sub in the coordinate minus tan Q. Why? Because point K lies on this line. That means my Y is now Q, my X is now 10, so my 3Q is now 40. Negative 4 times negative 10 is 40. 40 minus 37 is 3. My Q is 1. Okay, I've got my value of Q. Next, part C, I'm finding area of rectangle KLMN. So area of a quadrilateral, we can pick any point to begin with. You can do KLMN, any direction. But remember, if you use clockwise, it'll be negative. Anti-clockwise is positive, but we can sort of treat it as a modulus and take the positive answer since area is always positive. So I'm going to start with point K. K is minus tan Q. Q is 1. All right, I'm going to continue with L. P is negative 4 minus 7. M is 8, 2. And then N is 2, 10. And repeat the first point minus 10, 1. Okay, let us multiply downwards. This will be 70. This is minus 8. This is 80. Remember, we multiply downwards. They are all positive. Then you minus multiply upwards here. Oh, this is actually called a determinant of a matrix. It's a 2 by 5 matrix. Okay, so this will be minus 4 minus 56 plus 4 minus 100. All right, I know it's a bit hard to calculate mentally, so we're going to use a calculator. Here we have 70 minus 8 plus 10 plus 2 is 12. Then you minus open bracket minus 60 actually. It's okay, I can just show you one by one. Minus 4 minus 56 plus 4. The 4 cancel each other off. Minus 100. There you go. I got 2. Wait. Something is wrong somewhere. So maybe I typed wrongly. Okay, this one. 8 times 10 is 80. I counted this wrongly. This is 80. So let's do one more time. This one is 80. Let me insert. This will be 80. And then a 2. You can write 82. Okay. My answer is 300. Half of 300. Your area is 150 square units. Okay, next one, D. A fence is built with the condition that distance between the fence and point KM always 3 to 2. Point KM 3 to 2. So it's an equation locus. So we know K, the fence, I'm going to call it F, and another one is M, and F, the ratio is 3 is to 2. Okay, your fence is F, X, Y, or you can call it P. Normally, equation locus, we use P. Okay, instead of using F, I use P. Okay, P, KP, MP is now 3 to 2. So let's rewrite in the form of proportion. Proportion are basically two equivalent fractions. We cross multiply, and now we use the formula for distance. Okay, remember there's a 2 outside. Your coordinate point K is minus 10Q. So minus 10 minus a plus. Remember, I'm using formula for distance. If you can't remember, distance goes like this: x minus x1 square, y minus y1 square. Your x1 is minus your x1 is minus 10, minus a plus 10, and then your y1 is q. Q is 1, so y minus 1 square. This is 3 with the square root. X minus your m is 8, you square it, and your y is 2. Your m here is 8, 2. Okay, this is going to be a very long expression, so I probably have to move this a bit to the right, give myself a bit of space. All right, let's square both sides. 2, when I square it, I get 4. This is x squared. I hope we can expand this quickly by now. This is a squared 2ab. 2 times 10, 20 times x. 10 squared is 100. Then y squared minus 2 times negative 1 minus 2 times y minus 2y plus 1. And then 3 squared will give us 9. This is x squared minus 16x. 8 squared 64. this is y squared. Wait, I need to put y squared first, minus 4y plus 4. Okay, let's expand this bracket. This will be 4x squared. Now, at the same time, I like to arrange it. So let's do the y first. Let's do the y first. I'm going to do 1, 2 first. Okay, my y is going to give us 4y squared here, 4y squared. And then 20 times 4 is 80. 4 times 2 is 8y. Now, this is 101. A 101, because I'm going to add these two first. 100 plus 1. 101 I times 4. I got 404. Then 9 times x squared, 9x squared. Let's do the y first, 9y squared. 9 times 16 is 144x. 9 times 4y here is 36y. And then I have 64 plus 4, 68. 68, you times 9, it gives us 612. Big number. All right, 612. So let's bring everything to the right-hand side because the 9 is bigger than 4. So 9 minus 4 gives us 5. I rewrite the x squared first. And then 9 minus 4 again, another 5y squared. 144 plus 80 is 144. Is negative 144 minus 80 is negative 224. All right. And then minus 36 plus 8 is minus 28y. And lastly, 612, you minus 404, you get 208. There you go. That is your equation of locus representing the fence. Okay, let's move on to question number 11. So this is from the chapter, Form 5, Chapter 2, Differentiation. So the first part, you're finding F0. Okay, I'm just going to do it over here. F0 means we put 0 inside. So we get 2 times 0 over 3 minus square root 0 plus 9. So this is 0 over 3 minus 3, which is over 0, which is 0 over 0. And remember, 0 over 0 is actually undefined. It is not 0, it's not 1, it's undefined. Now, the easiest way to understand this is to pick a number. Like, for example, if I give you 2 over 2, right? We know 2 over 2 is 1. Now, if I pick a number very close to 2, for example, a number very close to 2 is 2.00001, and I divide with a number very close to 2, it doesn't matter whether it's more than 2 or less than 2. Even if you put 1.99999, right? Your outcome is always close to 1 or just 1. However, if I give you a number very close to 0, like 0.00001, and I divide by a number 0.001. Now, sometimes depending on how many zeros we have. Now, in this case, I got 1 over 10. But what if I increase or reduce the number of 0? Then I get a different number. If I increase the number of 0, I will get a different number altogether. That's why 0 over 0 is always undefined. We don't know exactly what is the value, right? Because a number close to 0, like this is 0, this is 1, 0.1 is close to 0, 0.01 is closer to 0, 0.001 is even closer to 0. The more zeros you have, the closer it is, right? But when you divide a number close to 0 with a number close to 0, we don't know exactly what it is, right? It is actually undefined. It's not 0, it's not 1, it's undefined. Okay, second part. We want to complete the table. Okay, so this part is an easy part. Yeah, this is the part of limit, but it's a bit annoying because you need to key in one by one. So I would expect, I will hope you guys know how to use the function here in your calculator. Let me just show you here. Type in 2 alpha x divide by 3 minus square root alpha x. X is this, alpha x, and then you plus 9. Okay, so we're going to use the calculate button. Press calculate, pick a number. The first number I'm going to add in is negative 0.1. Negative 0.1, you press equals. And you're supposed to give your answer correct to, let's see, the question say 4 decimal. If I can fix my decimal point, I press shift mode. I go to number 6, fix 4 decimal point. Then I press equals. My first Okay, calculate. My first answer is this, negative 11.9666. Negative 11.9666. Okay, the second one, I'm going to add in negative 0.01. So this is going to give us negative 11.9967. 11.9967. So next one, just increase the number of decimal point to negative 0.001. This is negative 11.9997. 11.9997. And the next one, calculate, put negative 0.3 zeros with 1. This is negative 12. Yeah, 12.0000, right? 4 decimal point. All right, let me repeat with the positive value 0.1. Okay, this is going to give us negative 12.0332. Negative 12.0332. Next one, I'm going to use 0.01. This is negative 12.0034. 12.0034. All right, next, I'm going to use more decimal point. 0.001. This is negative 12.0003, right? Okay, and lastly, 0.00001, I got negative 12.0000. Okay, so it's not difficult, right? Just sub in your calculator and calculate this value. And then they say, from the answer in the table, state the value of the limit of x approaching 0 for this. So the limit of this is of x approaching 0 of 2x of 3 minus square root x plus 9. You can see from the table, right? As your x approaching 0, it gets closer to 0. Your fx value gets closer to negative 12. All right, so this is for the whole thing for 4 marks. Okay, now what I want to say is this. It is actually easier. I mean, it's actually better for them to test you the ideal limit using simplification. Okay, so now this is not the solution for this question, but just so you know, in your new KSSM textbook, we have questions like this that you need to find the limit for this. And I need to simplify it by multiplying top and bottom with this. Yeah, this is something we can actually find without using a table. Okay, but I'm just showing you this is not a solution for this question, but just telling you that you can actually do it without the table. So when you multiply top and bottom with 3 plus surd x plus 9, we are actually simplifying this surd here. This will be the limit of x approaching 0 of 2x and 3 plus surd x plus 9. As for your denominator, you get 9 minus x plus 9. Remember, if you have a minus b, a plus b, when you expand, you get a square minus b square. In this case, 3 square is 9. Square x plus 9, you square it, you just get x plus 9. Now, let's simplify this further. This would now be 2x with the 3 plus square root x plus 9 divided by 9 minus x is negative x. 9 minus 9 cancel out, no more. And we can actually cancel your x here. Yeah, we can cross out the x from here and here. All right, so I'm left with a negative, right? So this is a negative 2 with the 3 plus square root x plus 9. Let me put a bracket here. And only at this stage, we sub in 0 inside. So it's minus 2, 3 plus square root 0 plus 9. This will be 3 plus 3, which is 6. 6 times 2, negative 2, negative 12. See, we'll get negative 12 as well without using a table, right? Okay, so that's part A. Yep. Let's move on to part B. Here we are supposed to express x d2y dx squared plus x in terms plus dy dx in terms of x. You're given your y is this. Okay, so first of all, let's expand the bracket. This is x power 3 minus 4x. When you differentiate dy dx, this is going to give us 3x squared minus 4. Right? I hope we know how to differentiate quickly by now. Bring the power down, copy x, reduce the power by 1. If you differentiate linear form, negative 4x, you get minus 4. When you do d2y dx squared, this will be 6x. Now let's take this and sub inside here. All right, so let me write down your x d2y dx squared plus dy dx is therefore x with the 6x, and your dy dx is 3x squared minus 4. Now this will give us 6x squared, and you plus with 3x squared minus 4, you get 9x squared minus 4. And from here, we're supposed to find the range of values of x such that this whole thing is greater than 0. So let's take 9x squared minus 4, let it be more than 0. Let us double bracket factorize it. This is 3x, 2, 2, 1 plus, 1 minus. All right, so we can sketch a graph. The roots are minus 2 over 3 and 2 over 3. More than 0 means it should be above here, right? I'm sure you know how to solve a quadratic inequality by now, right? So more than is the region above. So we say x is either less than minus 2 over 3 or x is more than 2 over 3. All right. Okay, moving on to section C, the first question, question number 12. This is from solution of triangle. So diagram 6 shows a triangle PQR where angle R is an obtuse angle, given that PQ is 7.2, QR is 3.646, and PR is 4.992. Okay, so they say without finding any angle, find the area. So when they say without finding any angle, right, we know we can use Heron's law. We have to use Heron's law directly. Some people may use cosine rule to find angle first, and then you use half AB sine C, but that would be wrong in this question because the question say without finding the angle first. Okay, so I'm going to start off here. Let me do it here. I'm going to use Heron's law. Heron's law works like this. We first take semi-perimeter. That means we take the length of all three sides, add them up, 7.2, 3.646, and 4.992, divide by 2. It's basically perimeter divide by 2. That's why we call it a semi-perimeter. Okay, let me just adjust my calculator first, clear all. All right, now let's add them up. The first one is 7.2, second one is 3.646, third one is 4.992. You divide by 2. So this value is 7.919. 7.919. Now remember, the formula for Heron's law, if you cannot remember, S equals A plus B plus C over 2, where A, B, C are the length of side, and your area is S. Take the difference between semi-perimeter and each individual side. All right, put a square over, get your area. So my first part is 7.919. Take 7.919 minus 7.2. 7.919 minus 3.646. 7.919 minus 4.992. All right, put a big blank here over here. Now let's count. Now for me, I like to use the answer button. That would be a lot easier. See, I already have this answer, 7.919. This is my semi-perimeter. So I press square root, press answer, open bracket, answer minus 7.2, close bracket, then answer again, minus 3.646, right? I do that because I don't have to retype 7.919 over and over again, right? So this answer minus 4.992, close bracket, press equals. There you go. My area is 8.439. 8.439. Okay. All right. Next, part B. Find angle QPR. So QPR is this angle. Now, I already have this area. right? So once you know this area, well, I think it's easier to use half AB sine C. Now, if you want to use cosine rule to recalculate the area, you can, but I like half AB sine C. But if you want more decimal point, just to make sure, you can write 8.43874 if you want. Yeah, 8.43874. Just use this just in case you find the answer is not that accurate if you want, right? But it's actually not necessary, okay? So I'm going to use half AB sine C. My AB will be, remember, formula for area triangle is half AB sine C, where AB will be this 2, C will be the angle in between here. In fact, you're finding the angle in between here. So let's take 7.2, 4.992 sine of angle QBR. This is 8.43874 if you want. If you take 8.439, I think it's good enough. So I'm going to take this answer, I'm going to multiply by 2, divide 7.2, divide by 4.992, press equals. Now, don't write the answer down first. Immediately use your calculator, shift sign, answer equals. That would be the most accurate answer, right? 28.01. Yeah, your angle QBR is 28.01. Okay, let's try with this, see whether answer a bit different or not. 8.439 times 2 divide 7.2 divide 4.992 equals, shift sign, answer equals. Yep, I still get 28.01. Yeah, so there's no difference using this or even more decimal point. All right, this is just the first part, right? Part A and B. I still have part C. All right, they say line PR is now extended to R prime with the condition that QR equals to QR prime and angle QPR is equals QPR prime. You're supposed to sketch triangle QPR. Okay, I know it's very hard to see it. My question is here, my diagram is there. So I'm going to redraw this diagram down here. All right, I hope it's not too different. All right, so let's do a sketch of this diagram. It looks like this: 1, 2, and 3. Okay, this one, it should be a bit sharper. One more time: 1. This one's a bit lower. 2. Not very nice. 2 and 3. Okay, this one's supposed to be a lot longer compared to this. Okay, so I've got my P, R, Q. Okay, so this is, I'm just redrawing the same diagram. You can just refer to your question paper. Your QR prime equals to QR and PR is extended. Yeah, so when you extend, it's going to be a bit longer here. And these two lengths must be about the same. So your R prime is over here. All right. So the condition is that QPR remains the same. Angle QPR remains the same. Now we know just now this is 28.01. This is 7.2. This length, if you refer to it, is 3.646. Yeah. This will be 3.646. 3.646. They are equal length. All right, so we are supposed to redraw triangle PQR prime. So let's just redraw. It looks like this. Okay, I better use a ruler. Looks nicer. 1. Okay. Okay. Wait. Let me just use this. Join together over here. Okay, the third one should be, okay, this one is a bit too long, make it a bit shorter. Okay, and the third line should be from this point to this point. Okay, so this is my PQR prime. This is 3.646, this is 7.2, and this is 28.01. Okay, so my sketch is complete. Now, next we are supposed to calculate angle QPR prime Q, which is this angle over here, right? So we can use sine rule. Okay, when you use sine rule, remember sine rule works in a pair. PR prime Q divide your opposite length is 7.2 sine 28.01 Your opposite length is 3.646. My angle PR prime Q is therefore, use your calculator, sine. Okay, let me type here. Okay, remember calculator must be in degree mode. When you use this, must be in degree. Yeah, sometimes you tend to forget because you change to radian, right? 28.01. Okay, whoops, sine 28.01. We divide by 3.646. You multiply by 7.2. Whatever we get here, we shift sign, answer equals. So I got 68.03. 68.03. All right, last one. We are finding the shortest distance from Q to straight line PR. Okay, shortest distance is a perpendicular distance. So we can extend this down here and make this a right angle. Now, we already know this angle here, 68.03. Now, you don't have to use a fancy sine rule, cosine rule to find the perpendicular distance. We can just use a simple trigonometric method. That means SOHCAHTOA. We use SOHCAHTOA because we already know this angle here. We know the length of your hypotenuse. This is a right angle triangle. Now, you can use any other symbol. You can call this n if you like. You can find and call the perpendicular distance as Qn. Here, I'm just going to call it h. So I'm going to use sine angle 68.03 is your opposite, which is h, or you can call it Qn, divide by your hypotenuse 3.646. Okay, use your calculator, multiply over. All right, so this is sine of this answer, 68.03. Then you multiply by 3.646. Okay, my answer is 3.381. 3.381. There you go. That's the shortest distance from Q to line P prime, PR prime. Okay, question number 13. So here we have a fishmonger who buys X kg of prawn, Y kg of stingray from a wholesaler. So the price of prawn stingray are 25 ringgit. Here, let me just highlight 25 ringgit per kg, 20 ringgit per kg respectively. So we have to, there are two constraints here. All right. So the first one, the mass of stingray is not more than 3 times the mass of prawn. Second one, total amount of prawn and stingray purchase is 800 ringgit or more. So we are supposed to write 2 inequality, pretty standard. Yeah, but usually they ask 3 inequality. In this question, they ask only for 2. Okay, so the first inequality, they say the mass of the stingray is Y, prawn is X. So Y must not be more than, that means less equals 3 times of X. Yeah, Y less equals to 3X. Okay, second one, total amount purchase is 800 ringgit or more. So you know, a kg of prawn is 25 ringgit. So 25 times X. 1 kg of stingray is 20 ringgit. So it's 20 times Y. So that's the total amount you spend in purchasing the prawn and stingray. And this amount must be greater equals 800. Now, actually, we can stop here. But when it comes to drawing graph, it's always easier to use a smaller number. Here, I'm going to divide everything by 5. So I got 5x plus 4y. When you 800 divide 5 is 160. There you go. That's your answer. If you, like I said, if you don't simplify, it's okay. Yeah? But I simplified. It's easier for you to draw the graph. Okay, next one. The third inequality is, the third constraint is represented by the color region on the graph right inwards. Okay, so first of all, you can see from this line, it passes through 100 and 100. So we can say that this equation is x over 100 plus y over 100 equals to 1. Do you know what is this? This is equation in intercept form. Now you can go and find the gradient, y-intercept. You can do that because your gradient is -1, y-intercept is 100. You can do that as well. So when you multiply by 100, your x plus y is just 100. So what does this represent? That means the total amount is The total mass is 100. Okay, however, look at the region that it represents, it's below. So your inequality is x plus y less equals to 100. But guys, we need to write in words. So this one, I just write in inequality. Please write in words. We say the total mass of prawn. Maybe I write below here, guys. Really, no space. The total mass of prawns and stingrays is less, not more than. It can be, you cannot say less than. It can be equal. So we say it's not more than. Less equals, not more than 100 kg. All right, so that is the answer for B. Okay, C, we are supposed to construct and build and construct and shade the region R that satisfy all three constraints. Well, the third constraint we already have. The first two, we need to draw the straight line. Okay, remember the first constraint I've got is y less equals to 3x. Okay, so maybe I just add in here. For y equals to 3x, if I use a table of values, we put x equals 0, y equals 0. So we know the first point is here. Now the second point can take any value if you like. Maybe I put x equals to 40, your y will be 120. X is 40, y is 120. So it's over here, right? So we're supposed to draw this straight line here. So make sure it passes through 0 and it passes through this point here. All right, don't draw anything bigger than that. I think this is good enough. This is y equals 3x. Okay. All right. So next, I need to draw the second one. The second one is 5x. Let me write here. 5x plus 4y equals 160. So again, table of values, x and y. When you substitute x with 0, 160 divided by 4 is 40. So it's 0, 40 here. When I sub y with 0, 160 divided by 5 is 32. Okay, 32 is over here. Now, why do I do this? Because I let my x be 0 to find my y-intercept. I let my y be 0 to find my x-intercept. Yeah. So once you can find these two intercept, we can actually draw a straight line. Yeah. So actually, you can use any other point you like, but it's just that intercept will be a lot easier, right? A lot easier to map it on the graph. You can see 0, 32, and 0, 40, and 32, 0. Okay, I hope you can see this. This is 32. This side here, this is 32. Okay, so this equation is 5x plus 4y equals 160. So we are supposed to construct and shade the region. Now remember, the three condition. Number one is x plus y less equals to 100. This is already drawn for you. Second one, your y must be less equals to 3x. That means it must be below this region. So maybe I use a different color, blue color, below here, right? And number three, it must be above here. It must be at least greater equals to 160. Yeah? So it must be above here. So I know it must be above this line. So let me just shade here and label it with a symbol R. R is the region that we want. Okay, now we're done on the graph here. Next, using the graph that we have here, we are supposed to find the minimum mass of prawn purchased if 20 kg of stingrays is purchased. Stingray is Y. Prawn is X. So we need to find X when your Y is 20. So very simple. Look at the graph. When your Y is 20, your X, the minimum is here. We need to move it down. It looks like it is 16. 16. All right. So answer, the minimum, X minimum is just 16. You can just write 16. Okay. Next, the maximum amount money paid. Right. Now, the maximum amount of purchase, the minimum amount of purchase is 800. So the objective function is actually this, right? But we just have to let it be K. Yeah, K is what we want to find. The minimum purchase is 800. The maximum purchase, I don't know. So maybe I let it be, let me write here, the maximum amount purchased. Let me write over here. Wow, a bit hard to see. Hope you can see it. It is, we have 25x, 20y equals K. 25x, 20y equals K. So this is an objective function representing the amount purchased. Okay. Now remember, this line is actually parallel to this line earlier. The line earlier here is actually 25x plus 20y equals 80 because this is a minimum purchase, right? Your maximum can be more than that. So we need to draw a line that's parallel to this and move it up such that the line must pass through at least one point in this region. So let's draw a line that is parallel to it. It looks like parallel, right? But I need to move this line up here. Okay, now I know this is a bit hard for me to move. All right, I need to move this line up, here, such that it's maximum, such that it gives us the largest y-intercept. Remember, the larger the y-intercept, the larger the value K. So obviously, this is not the largest point. Yeah, I want to take this point. We take the 4 vertices. This point doesn't give us the largest y-intercept. Why? Because there's another point, right? That point is actually here. Can you see? Is over here. This point will give us the largest y-intercept. Now, you don't have to draw very long. Some people, we normally draw a dotted line, but in this case, sorry, I draw a solid line for you. We will write this as 110. That means if you buy prawn and no stingray, that you will spend the most, the maximum purchase. So based on this graph, we can see that K is maximum at 100, 0. So your maximum value of K is 25 times 100 plus 20 times 0. That will give us RM 2,500. Yeah. So the maximum amount is 2,500. Okay. This is not a difficult chapter, but I know a lot of people probably don't want to do this because you probably prefer solution on triangle index number, right? Because it's easier. This is a little bit more troublesome. You have to draw the graph. Yeah. But it's not difficult. For this question in particular, I think it's quite straightforward. Okay, question number 14, right? So this is from Kinematics of Linear Motion, Form 5, Chapter 8. So here we have a snooker ball that moves along a straight line, passes through fixed point O as shown in the diagram. Initial velocity is 40. Acceleration is given by this. All right. So we are finding the displacement of the snooker ball when the acceleration is 0. Okay, so let your acceleration be 0. Take 16t minus 48 equals 0. 16t is 48. T is just 3. Now, the thing is, we need to find the displacement. But we don't have displacement function. We don't even have a velocity function. Remember, if you differentiate displacement, you will get velocity. If you differentiate velocity, you get acceleration. To find acceleration, to find displacement from acceleration, you have to integrate one time to get v, integrate second time to get s, displacement. So let's start by integrating 16t minus 18 dt to get your velocity function. Remember, in integration, we increase the power by 1, divide by the increased power. 16 divided by 2 is 8. 48, when you integrate, is negative 48t plus c. I need to find the value of c. Now, it is given that initial velocity is 40. So when t is 0, v is 40. So your c is 40. My displacement is, my velocity function is 8t squared minus 48t plus 40. Now next, we integrate one more time. Now, the second time you integrate is to find the displacement function. Yeah, I already got my velocity function. I integrate velocity to get displacement. So in this case, you get 8t cubed over 3 Now let's take t square root, divide by 2. 48 divided by 2 is 24. This is 40t plus c. Now, to find the value of c here, we sub in. We know when you start the clock, t is 0. Your s in this case is 0. Why is it 0? Because they say after passing through point O. O is your starting point. So imagine if I put 0 inside s, t also 0. Therefore, my c is also 0. My displacement is therefore 8t cubed over 3 minus 24t squared plus 40t. I know this is very long. And now we sub in t with 3. When t is 3, s is 8 over 3. 3 cubed is 27. 24, t squared, 3 squared is 9 plus 40 times 3. Okay, let me use a calculator and calculate. This is 8 over 3 times 27 minus 24 times 9, and then you plus 40 times 3. My answer is negative 24. Since the question say displacement, so displacement can be negative, so we leave it as negative 24. Okay, next, find the time when the snooker ball changes direction. Okay, now we know the ball or any object will change direction when the velocity is 0. Since I already have my velocity function, I'm going to sub in 8t squared, 48t plus 40, let it be 0. Let us divide by 8. So t squared minus 6t plus 5, let it be 0. Let's double bracket factorize this. All right, your factor should be 5 and 1, minus and minus. So your t values are 1 or 5. There are two values. Find the time. The time is 1 or 5 seconds. Yeah, so it actually changes direction twice. Okay, lastly, part C. Show that the snooker ball is moving to the left when the acceleration is 16. Okay, so when your acceleration is 16, we need to find the time. 16t minus 48 equals 16. 16t is 48 plus 16, 64. T is 4. To know whether it's moving left to right, we just have to find the sign for your velocity. So we take this t value, sub inside your velocity function, 8, 4 squared. I'm substituting inside here, 4 squared. I'll write 16 straight away. Don't write a lot of step. 4, t8 times 4 plus 40. Okay, let's count. Now, let's use your calculator here. This is 8 times 16 minus 48 times 4 plus 40. There you go. My answer is negative 24. Now, the most important thing is not the value, not the magnitude. It's the sign here. Your V is less than 0. So, meaning, okay, the snooker ball is moving to the left. That's all. Yeah, it's moving to the left. Yeah, we show less than 0. Yeah, we know it's moving to the left. Okay, last question, question number 15. This is from the chapter index number. So table 3 shows the price indices and percentage of usage of 4 components A, B, C, and D in the production of a fan. So calculate the price of component C in year 2021 if the price in 2019 is 75 ringgit. So let's focus on component C. So the price index is 145. So you know that price index is the price in the current year, which is 21, price in the base year, which is 2019 times 100. So we know the price index is 145. The price in the current year, which is year 2021, I don't know. Price in the base year is 75 ringgit. You multiply by 100. Okay, very simple. Just multiply this over. So I'm going to use 145 times 75 divide by 100. So my price is 108.75. Yeah, RM 108.75. Okay, next one. The composite index for the production cost of the fan in the year 2021 based on 2019 is 130. Find the value H. So H is an unknown. Yeah, H is the price index for component B. Now, usually any other information given in the form of pie chart, bar chart, or percentages, they are your weightage. So for me, normally I'll simplify the weightage, easier to calculate, divide everything by 10. All right. And remember, composite index, in this case, is 130, right? So we're going to multiply the individual price index, 138, multiply with 1, H, multiply by 2, I write 2H, 145, I multiply by 4, 108, I multiply by 2, divide by your total weightage, 1 plus 2 plus 4 plus 2, your index is 130. Okay, so let's count. 138 times 1 is 138. You plus with 145 times 4, and then 108 times 2. So this will give us 934. 2H plus 934. This is now 10. If you multiply over 1 plus 2 plus 4 plus 2 is 10. It's 9, right? So, yeah, did I make a mistake here? 1242. This is 9 actually. 1342. I wrote this wrongly. Sorry. This is 1342. Okay. 1342 is 10. So it's 1300. So let's bring it over. 1300 minus 936. Okay. I'll show you. You actually can do mentally. 936. I got 364. Right? That 364 I divide by 2. I get 18. Divide by 2, divide by 3, sorry, this one I wrote wrongly just now. It affects the answer. This is 3H, sorry. 3H, 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 you divide by 3, you get 136, 36. Okay, I make a mistake here. This is 936, 934. I wrote 936 just now. It's 366. Divide by 2, divide by 3, 122. Sorry, 122. Okay, now the next thing is this. From 2000, from the year 2021 to 2025, yeah, this component B increased by 15%. Okay, okay, maybe I write here. This is 2021 to 25. When it increased by 15%, the index is 115. Okay, component D decreased by 10%. Decreased by 10% is 90. Remember, unchanged is 100. Increase by 10% is 110. Yeah, if you increase by 10% is 110. You drop by 10% is 90. It remains unchanged is 100. Right? So index everything is based on 100. Yeah, more than 100 increase, less than 100 reduce. Okay, coming back to this, the rest remains unchanged. A and C remain unchanged. We're at 100 and 100 here. Okay, to calculate the composite index for the fan for the year 2021 based on 2025 based on 2019, you need to recalculate the individual index. Okay, so let me just show you one example to help you to understand. So if you have item A, right, there are 3 consecutive years involved: 2019, 2021, and 2025. From 19 to 21, A increased by 38%. We're at 138. From 21 to 25, it doesn't change, so it's 100. To calculate the overall increment, the index is calculated this way. We take 138 times 100 divide by 100. So it's still 138, right? It's always 2 consecutive indices multiplied together divided by 100. But for B, right, I really know my H is 122, right? So I repeat the same process. Don't have to recalculate, don't have to redraw the diagram. We take 122, we multiply 115 over 100. Okay, let's count. 122 times 115 over 100. This will give us 140.3. Yeah, 140.3. So let me write here 140.3. Now, for item C, component C, the index is now 145 times 100, because it's still unchanged over 100, still 145. For component D, your index is 108 times 90 over 100. Okay, let's count. 108 times 90 over 100, it gives us 97.2. Okay, so now that I know all these indices, right? So the next thing to do is to multiply with the weightage. We know the weightage is 1342, right? So let's take the composite index. This will be from 2019 to 25. So we take 138 multiplied by 1, take 140.3 multiplied by your H, this one is 3, and then 145 times 4, lastly 97.2 times 2, divide by total weightage is 100. I don't have to recalculate. We know total weightage is 100. Okay, let's move it over a bit. Now, use your calculator. All right, 138 plus 140.3 times 3, 145 times 4. Next one, 97.2 times 2, divide by 10. Okay, my answer is 133.33. 133.33. Okay. Now, we're not done yet. This is just C Roman 1. C Roman 2. Okay, if the production cost of the fan in 2019 is 128 ringgit, calculate the corresponding production cost of the fan in the year 2025. So here, this is a assumption when your overall cost of the component increased by 33.3%, so your overall production cost must increase at the same rate. So we know we can say the price in year 25 divide price in year 2019 times 100 must equals this composite index. So we're going to find the production cost in year 2025. All right. In 2019 is 128. You multiply by 100. This is 133.33. Okay. Use our calculator. All right. 133.33 multiply 128 divide 100. There you go. 170.66. This is RM. RM 170.66. All right, so we are done with the discussion of this Selangor paper 2. I hope you learned a lot in the process. We enjoyed this video. Thank you. I'll see you guys in the next video.